Hey everyone, in this video we'll be going over 3 SAT non-calculator problems. So the first problem is, the lines in the xy plane above are the graphs of two linear equations. What is the solution xy to the system formed by the equations? So when we see two given lines, or just two given equations in like a system of equations, we know that we're trying to find its intersection point, which is the solution. So the solution is equal to the point of intersection. Now, this point of intersection in a system of equations, when you're just given two equations, can be found by substituting in variables or different methods. But when we're given two lines, it's as simple as finding where these two lines intersect on the graph we're given. And they clearly intersect at this point here, and that would be -1 and +2. So -1, +2, and our answer is B. So now, for the second problem, our question is, what is the sum of 3x to the power of 5 plus 4x squared plus 8 and 12x cubed minus 2x squared plus 6? Now, just finding the sum. The sum is the key word here. So we're not multiplying the two equations, we're actually just adding them. And you have to make sure that you watch out for that word because it can sometimes trip you up. But we just have 3x to the power of 5 plus 4x squared plus 8 plus 12x cubed minus 2x squared plus 6. Now remember, in situations like this, you can only combine, you can only combine your like terms. So that just means you can only combine terms with the same exponent. So in this case, the terms we can combine are, we can combine 3x to the power of 5 with nothing, so that stays the same, 3x to the power of 5, plus 4x squared. Let's look for another term with that is squared, and we have minus 2x squared over here. So we can say 4x squared minus 2x squared is plus 2x squared. Now let's look for anything with no exponent, or just a regular number, and we have a 6, so plus 14 plus, and our final term that's left is 12x cubed. So our final answer is 3x to the power of 5 plus 12x cubed plus 2x squared plus 14. And that is answer choice B. So this is our answer choice. So now moving on to the third one. Our question is, a checkers enthusiast is customizing a checkers set by painting a design on each of the 24 checkers in the set. It takes the enthusiast 35 minutes to paint the design on each checker. If C of the checkers are already painted, which of the following represents the number of additional minutes needed to finish painting the set of checkers? So, to start, we have a checkers enthusiast is combining a checker set by painting a design on each of 24 checkers. So we know that 24 checkers in total, and it takes 35 minutes each. So we can say 35 times number of checkers, because to know the number of minutes, because the 35 minutes for each checker, and if we know the number of checkers, then we can get the total amount of time it'll take to paint each one. And if C of the checkers are already painted, which of the following represents the additional number of additional minutes needed to finish? So using what I said earlier with the 35 times the number of checkers, what we can do is we can just take 35 once again, which is our minutes, and multiply it by the number of checkers we have left to paint. So we're only multiplying it by the number of checkers that are left. And we know that there are 24 in total. So total checkers minus the number that is already painted. So already painted. And 24 minus C will get us the number that is left, the number of checkers that are left that have to be painted. So 35 times 24 minus C is our final answer.